Hi guys. So when you work on the data science projects, many times you would get features which are on different range. So for example, let's say that you are working on a project where you want to cluster all the customer data. And in the customer data, you have information about, let's say, the salary of a customer, the EMI value of the customer, then the amount of transaction they have done, let's say in last 12 months, then the number of transactions they have done in last 12 months. Then let's say what's the percentage of purchase they are doing online versus offline. So let's say that all this information you have about the customers and you want to apply clustering on that customer data to identify the patterns. Now, whenever you want to apply clustering, like let's say k-means clustering, it is going to use Euclidean distance metric, which would get impacted if all your features or your columns are on different range. So you directly, if you apply k-means clustering without scaling or without normalizing that data, your results won't be having a high quality results, because some features which are having higher range, higher values would actually drive that k-means clustering. So when you apply and work on data science projects for many algorithms, it is very important to scale your data. So in today's video, what we would do is we would discuss about data normalization and how you can do that using Z-score normalization and min-max normalization. And along with that, we would also take some data set and we would apply these methodologies on that data set to check if you are able to successfully apply this data normalization using Python. Let's get started. So when you have to normalize your data, typically there are two methods which are used for normalizing your data. The first method is Z-score normalization. So let's say that you want to transform your features in such a way that every feature has a mean value equal to 0 and standard deviation equal to 1. In that case, you can use Z-score normalization. So typically in dimensionality reduction algorithms like principal component analysis, you need a data which has 0 mean. So in that case, Z-score normalization is useful. So this is how the Z-score normalization works. So after you apply the normalization, the new value of the feature would be equal to its current value. Then from the current value, you would be subtracting the mean value of the feature, and that difference you would be dividing it by the standard deviation. So basically for every feature, every column in your data, its mean and standard deviation value is calculated, and using that mean and standard deviation value, a new value is created. And this new column which is created after applying Z-score normalization, that new column, that new feature would have mean value equal to 0 and standard deviation equal to 1. So this is Z-score normalization. Now let's say that in some algorithms like let's say k-means clustering, it is better to have all the features exactly in the same range. So Z-score normalization doesn't guarantee that all the features would have exactly the same range. So the range would be comparable, but it cannot be exactly same. But let's say that you want to create a features where all the features have exactly same range, like let's say 0 to 1. Then in that case, you can use min-max normalization. So in min-max normalization, the new value of the feature would be equal to its current value. Then from the current value, you would be subtracting the minimum value of that column and dividing this difference by the difference between max and mean value. So this is how you convert your data into a fixed range of 0 to 1 using min-max normalization. So let's take some data set now, and on that we would apply the Z-score normalization and min-max normalization to see exactly in which range the data is transformed after applying these methodologies. So here I am reading the data using the read CSV function from pandas. So this is the data related to the diamonds. And if you see here, we have information about the carat of a diamond, then the table, the depth, width, length, and the price. So we have multiple columns where we have information about a diamond. So if you see now, if we apply the describe function on this data set, so we are reading the data set in data frame df. So if I apply describe function on it, I would get to know what is the minimum and maximum value in every column. So for example, in column carat, the minimum value is 0.20 and the maximum value is 5. In column table, the minimum value is 43 and maximum value is 95. So if you see all the features, so for example, in price column, the minimum value is 357 and maximum value is 18823. So basically all the columns are on different range. All the columns are having different minimum and maximum value. All the columns are having different mean value, different average value as well. So let's try to apply Z-score normalization first on this data and check if we can transform this data into a data where all the columns are having mean value equal to 0 and standard deviation equal to 1. So for applying Z-score normalization, you will have to import standard scalar from scikit-learn pre-processing module. So I'm importing that. And after importing standard scalar, I'm just initializing it in a variable. So I'm creating a new variable Z score scalar, and in that I'm initializing a standard scalar. Now we can use this for applying Z score normalization on our data set. So for that, we'll have to call fit transform function. So I'm using the Z score scalar which we have created, and I'm applying a fit transform function on our data frame. So this would basically calculate the mean value and standard deviation value for every column, and using that it would transform every column in such a way that all the columns are having its mean value equal to 0 and standard deviation value equal to 1. And this result that we would get would be in the form of numpy array. So we want to transform that result in the form of data frame so that it becomes really easy to work on it. So that's what we are doing over here. So I am storing the scale data into new variable now, and after creating this new variable, I am just printing the top 10 rows. So these are the top 10 rows of this data. So if you see this data set now, all the data points are on different range now. So we don't see very high value, for example, in price, because we have applied Z-score normalization. So it should create data points such that the mean value is 0 and standard deviation is equal to 1 for every feature. Now we can check that again by applying a describe function on this scale data. So on the scale data, I'm applying a describe function now, and let's see what kind of a mean and standard deviation value we are getting. So if you check mean value of all the features, it is almost 0. So 2.41 into e raised to minus 16. It means that this floating point, I have to move it to the left by 16 positions. So that is basically nothing but equal to 0. So all the features now, they have their mean value or average value equal to 0 after applying Z-score normalization. And if you check their standard deviation, all of them are having standard deviation equal to 1, exactly equal to 1. So this is the property of Z-score normalization. So when you apply Z-score normalization on any data, it would transform your data in such a way that all the features have mean value equal to 0 and standard deviation value equal to 1. So we have successfully transformed our data using a Z-score normalization. Now let's say that you wanted to use this data for something like k-means clustering, because you want to identify the patterns that are there certain types of diamonds where the price is on a higher side, for example. So you want to just cluster all the diamonds data and find out the patterns. Now all the features, they are in different range. So even after Z-score normalization, if you see, the minimum value for caret feature is minus 1.25 and maximum is 8.80. Then for table feature, minimum value is minus 6.4, maximum is 1.68. So Z-score normalization cannot guarantee the mean and max value, but it can guarantee you the average value and the standard deviation. But if you want features in the fixed range, let's say all the features in the range of 0 to 1, then you can apply mean max normalization. So let's try to apply it in Python. So here I'm importing mean max scalar first of all from the scikit-learn preprocessing module, and then this mean max scalar I'm initializing it here. So I'm initializing a mean max scalar and storing it in a variable mean max scalar. Now using this variable, we can now apply min max scaling on our data frame. So I'm using this min max scalar and calling a fit transform function on our data frame. So what this would do is, for every column, first of all, it would calculate its minimum and maximum value, and using that value and using this formula which we have discussed, it would convert every data point, every feature in a range of 0 to 1. So we have applied the fit transform function on our data set. So it would now convert every data point in the range of 0 to 1. So if I check now the top 10 rows of our scale data, you would see that there is no data point which is less than 0 and there is no data point which is higher than 1, because min max scalar, it converts the data in the range of 0 to 1. And now we can verify that using a describe function. So I'm calling a describe function now on our scale data which we have scaled using min max scalar. Now if I check all the features, for example feature caret, the minimum value of it is 0 now and the maximum value 1. So for all the features now, they have their minimum value equal to 0 and maximum value equal to 1. So this is how we have successfully scaled our data into range of 0 to 1 using a mean max scalar. So using these scalars is really easy. When you use it in Python, you don't have to write a formula, but it's important to understand those formulas because you should be able to explain how exactly these functions transform your data into a data of, let's say, mean 0 and standard deviation 1 when you apply Z-score normalization, and data of minimum value 0 and maximum value 1 when you apply a mean max scalar. So this is how you can apply scaling in Python. So I hope you are clear now that how you can normalize or scale your data using Z-score normalization and mean max scaler. Now you can try some another data set and try to apply these normalization methods on those data sets. So this is how you would gain some confidence in applying normalization on your own. Thanks for watching the video, and I will see you in the next one. Bye bye.